In this video, we're going to talk about the U substitution technique for integration. This is also known as undoing the chain rule for derivatives. So we have to have a strategy for undoing the chain rule, right? We've figured out how to undo the sum and difference rule, the power rule, the basic exponential rule, but how do we do some of the undo some of the more complicated derivatives that require the use of the chain rule? So here are our 6 basic steps. Step number 1 is choose U. This was what we would normally consider to be the inside when doing the chain rule. Then we're going to compute the derivative of U with respect to x. Next, step 3, we'll solve for dx. Step 4 is the substitution part of this technique. We're going to substitute U in for what we chose for U, and we're going to substitute out dx and replace it with what we compute for dx. Step number 5 has 2 asterisks, because often students forget this step, is the integrate step. And the last step is substitute out U and replace it with what we originally chose for U. Our goal in step 4 is to get one of the following after simplifying. Our goal is to get basically a power rule, right? This is the simple power rule. U raised to a power, right? Simple power rule. And when we apply the simple power rule, which is add 1 to the exponent and divide, then we get that result. The next one is basically the logarithm rule, right? This is the ln of U plus c. And the last one is the exponential rule, which the antiderivative of e to the x is e to the x. So if I change the variable, it doesn't matter, e to the u, the antiderivative of e to the u is still e to the u. So that's my goal in step 4, is to get one of these 3 after simplifying. In this video, we're going to focus on this first one. In other videos, we'll focus on 2 and 3, or maybe a combination of, okay? Is number 1 here, right? That we said that was our goal of step 4, is to get the following after simplifying. So U raised to a power, and that power is not -1. So let's start with an example. X squared minus 1 to the 3rd power times 2x dx. So if we have our steps written down, step 1 is to choose our U. And we said we want to choose our U to be basically the inside, right? So I would consider this to be the inside. So that's what I'm going to choose for U. U is going to be x squared minus 1. Step 2 is compute the derivative of U with respect to x. So the derivative of U with respect to x is 2x minus 0, or 2x. Step 3 is we're going to solve for dx from what we have in step 2. So we've got du over dx is equal to 2x. So dx is down in the denominator, and so we're going to treat this like a fraction, right? Du over dx. And so I'm going to do a little cross multiply here, right? So multiply both sides by dx. That results in du is equal to 2x dx. And then the last thing to solve for dx is I'm going to divide by 2x. So this gives me du over 2x is equal to dx. So that's what I'm going to replace up here. So step 4 is the substitution step. So that's what's going to happen up here. This is step 4. So anything that has a box around it is going to get replaced. X squared minus 1, this is what I chose for U. So that's going to be U, but it's raised to the 3rd power. Dx, or 2x, does not have a box around it, so it stays. And then dx has a yellow box around it, so it gets replaced by du over 2x. Now step 4 is substitute and simplify. So I'm going to notice, by using the way that fractions work, that du over 2x times 2x is the same as 2x over 2x du, right? Do a little multiplication here. And so 2x over 2x is 1. And I'm left with u to the third du, which, if we go back briefly, so if we come back here, we're ready for step 5, which is to integrate. So the antiderivative of u, which is just our variable, it's just like x, is 1 over 3 plus 1, u to the 3 plus 1 plus c, or in other words, 1/4 u to the 4th plus c. And then step 6 is substitute back again. So I have a u in here, but that's not what my original problem was about. So I'm going to take back and replace it with 1/4. What was u? U was x squared minus 1 to the 4th power plus c. So I just made a nice little substitution here. I replaced u with x squared minus 1. And I'm all done. We can definitely verify that with a quick derivative, but that is my final answer. Okay, ready for our next example. Okay, we have x times the quantity 1 minus 2x to the 4th to the 5th power dx. Step 1, choose u. And again, we want to choose what would be the inside. So that's what I'm going to choose. Step 2, find the derivative of what we chose for u with respect to x. So this is going to be 0 minus 2 times 4, which is 8, x to the 3rd. So negative 8x to the 3rd. Oh, this should have a 3 on it. Sorry. There we go. Fix that. Okay, so that should have x cubed times 1 minus 2x to the 4th raised to the 5th power. Step 3 is we solve for dx. So I have negative 8x cubed is equal to du dx. So multiply both sides by dx. So I get negative 8x cubed dx is equal to du, and then divide to get the dx all by itself. So we get dx is equal to du over negative 8x cubed. So I'm ready to substitute. Okay. We said in step 4 we're going to substitute out what we chose for u and the dx, nothing else. Everything else stays. Everything else that is not in a box or not in a different color stays. So this is x cubed u to the 5th power. Right? I did that substitution here. Take out 1 minus 2x to the 4th and replace it with u. And then dx is du over negative 8x cubed. So that's step 4 here. And we're not quite done. We want to do some cleaning up, some simplifying. So I noticed this negative 8x cubed down here in the denominator. And again, by multiplication with fractions, we can slide that negative 8x cubed under the 8x cubed. X cubed over x cubed is 1. So this simplifies to negative 1/8 u to the 5th du. And I have that format I was looking for, u raised to a power that is not equal to negative 1. So step 5 is the integrate step. The antiderivative of u to the 5th is 1 over 5 plus 1, u to the 5 plus 1, plus c. So this is 1 over 6, so 8 times 6 is 48. And last step, is substitute back again. So I have my u, and I want to replace it with 1 minus 2x to the 4th to the 6th power plus c. So my final answer, negative 1 over 48, 1 minus 2x to the 4th, x to the 6th, or sorry, all to the 6th, plus c. And again, we can verify that we would get x cubed times 1 minus 2x to the 4th to the 5th by finding the derivative of our answer, right? Because that's what we're looking for here, right? An antiderivative is find me the function whose derivative is the function that is given. Got 2 more. So let's check our next example. This one is x minus 3 to the 5/2 power. Choose u. So again, inside, right? So that's what I'm going to choose. Step 2, find du dx, the derivative of u with respect to x. So du dx is 1 minus 0, or 1. Solve for dx. Well, du over dx equals 1. I'm going to multiply both sides by dx. And I get du equals 1 dx, or just du equals dx. So that's going to be my substitution. Okay, so again, anything that has a box around it is going to get replaced. Anything that doesn't have a box stays. Right, this is a 1-for-1, right? Du equals dx. So there's nothing else I've got to replace. And here u was x minus 3, so I took out x minus 3 and replaced it with u. So that's step 4. There's really not any simplifying that needs to be done in this one, which is nice. So I'm ready for step 5, which is, oops, nope, not that. It is find the antiderivative. So the antiderivative is going to be 1 over 5/2 plus 1, u to the 5/2 plus 1 plus c. 5/2 plus 1 is 7/2, and 1 divided by 7/2 is the same as multiplying by 2/7. Okay, 1 divided by 7/2 is 1 times 2/7. And last but not least, we substitute back again. 2/7. U gets replaced with x minus 3 to the 7/2 plus c. Okay, so make sure you're following the steps, right? Be methodical here. Make sure you're following your steps and use different colors like I do, right? Put boxes around things so you know exactly what gets taken out and exactly what gets replaced. We've got one more. All right, so first thing is I'm going to rewrite this using my algebra skills. Yep, skills with a Z, right? The square root is 1 minus x cubed to the 1/2 power, but then when I bring it up to the numerator, it becomes a negative 1/2 power. So I'm going to choose u. Again, it's the inside, right? What's inside the parentheses, or what we would have multiplied by the derivative of in part of the chain rule. Let me make that a little clearer. That's a little messy. There we go. And step 2, find du dx. So the derivative here is 0 minus 3x squared, or negative 3x squared. 3, solve for dx. So I have du over dx is equal to negative 3x squared. So multiply both sides by dx. And then finally, to get dx by itself, we're going to divide both sides by negative 3x squared. So we're ready for step 4. Let's see, let's clean it up. Du over negative 3x squared equals dx. So then I can put a nice box around it to show what we're going to replace. There we go. All right, x squared, 1 minus x cubed is u to the negative 1/2. The other item that has a box around it is the dx, so I'm going to use this here. So dx gets replaced by du over negative 3x squared. And I notice I have an x squared over an x squared, so that's equivalent to 1. So I have 1 over negative 3, so negative 1/3 u to the negative 1/2. Right, x squared u to the negative 1/2 du over negative 3x squared is the same as x squared over 3x squared times u to the negative 1/2 du, right? Because these are all considered under 1. So the way that multiplication of fractions work, this works out just fine. So the next step is to perform the integration, integrate. So u to the negative 1/2 plus 1, divide by negative 1/2 plus 1, plus c. And negative 1/2 plus 1 is 1/2, so 1 divided by 1/2 is actually 2. Right, 1 divided by 1/2 is the same as 1 times 2 over 1, which is 2. And then last but not least, I'm going to replace u back to 1 minus x cubed and to the 1/2 power plus c. Okay, so again, follow your steps. The steps are laid out nicely for you. Just follow them, right? Don't second guess them. Don't second guess yourself. Just follow.